Hey guys, welcome to this video on 7.50 and negative exponents. Make sure you have a piece of paper out and ready to go so you can take some notes. The first thing you should write down is the title on the top of your page. Alright, let's get started. First, we're going to talk about to the power of 0. What do you think it means when you have either a number or a variable or something raised to the power of 0? For example, if you have x to the power of 0, what does that mean? How could you evaluate this? How could you find out what that's equivalent to? What if you had 5 to the power of 0? What would that mean? Go ahead and think about it, and you can pause the video to make a prediction. Alright, now let's talk about it. This is actually super exciting stuff. I really wish that I could be there with you guys in person because this is a pretty cool lesson. So we're actually going to figure out what happens when you raise things to the power of 0. And in order to do that, we're going to start by writing it as a division problem. In your notes, can you guys write down x to the power of 10 over x to the power of 8? What have you already learned about how to divide using exponents? You know that when you're dividing using exponents, you can subtract the exponents. So x to the power of 10 over x to the power of 8 is going to equal x to the power of 2 because we subtracted the 10 minus the 8, which gave us the 2. All right, now write this problem down. X to the power of 7 divided by x to the power of 7. If we were using our subtraction rule for exponents, we would say, well, 7 minus 7 is 0. So this is equal to x to the power of 0. But let's back up a second. If we look at this fraction that we wrote down, x to the power of 7 over x to the power of 7, what other number is that actually equal to? In order to figure out what other number that's equal to, think about this problem that I'm going to draw over here. 4 over 4 equals what? You can simplify it. It equals 1. 3 over 3 equals also 1. X over x equals also 1. So x to the power of 7 over x to the power of 7 equals, well, it should also equal 1. But hold on a minute. Didn't we already say that x to the power of 7 over x to the power of 7 equals x to the power of 0? Why, yes, we did. X to the power of 0 is actually equal to 1. I know it's crazy, isn't it? The rule about raising things to the power of 0 is actually that it will equal 1. It will always equal 1. Anything to the power of 0 equals 1. X to the power of 0 equals 1. 5 to the power of 0 equals 1. Anything to the power of 0 equals 1. In your notes, can you write down that sentence in your notes? That's the sentence you should be writing down in your notes. Anything to the power of 0 equals 1. There are two very, very important key concepts for today, and this is the first one. Anything to the power of 0 equals 1. We're going to do a few practice problems to kind of see what an example problem would look like if it has something to the power of 0 in it. And remember, anything to the power of 0 equals 1. As we do these 4 practice problems together, there are 2 vocab words that are important for you guys to make note of. The first vocab word is simplify. If a problem asks you to simplify, oftentimes they would like for you to leave your answer with exponents in it. For example, 3 to the power of 5 would be a good answer to write. However, if a problem uses the word evaluate, in that case, your answer should just be a number without exponents. Your numbers might be quite large since we're using exponents, so you might have an answer of 1,742 or 216. So when the question says evaluate, we're just looking for a number. When it says simplify, we want it to have exponents. Now number 2 says simplify and evaluate. So after we simplify it, we are going to evaluate to find out the actual number without using exponents. Let's take a look at problem number 2. Simplify and evaluate 7 to the power of 3 times 7 to the power of 0. Well, what did we just learn? 7 to the power of 0 equals 1. And what is anything times 1? Well, it's just whatever that number is. So this is just 7 to the power of 3 times 1, which is 7 to the power of 3. But that's not our final answer because it said, and evaluate. When we evaluate it, we want to multiply 7 times 7 times 7 3 times, and we want to find out what number that's actually going to equal. You guys will be able to use a calculator for this. Go ahead and grab out your calculator, type in 7 times 7 times 7, and you should get 343. Because it said evaluate, that's our final answer, 343. Let's take a look at the next one. Number 3 over here says simplify and evaluate. 1 times 10 squared plus 2 times 10 to the power of 1 plus 3 times 10 to the power of 0. According to PEMDAS, we have to multiply before we add, so we are going to simplify this part and this part and this part here, and then we're going to add them together. 1 times 10 to the power of 2, that's just going to be 10 to the power of 2. 2 times 10 to the power of 1, I know that 10 to the power of 1 is just 10, and 2 times 10 is 20. 3 times 10 to the power of 0, remember, anything to the power of 0 is 1. 3 times 1 is 3. Let's continue to simplify this first part here. 10 squared, that's 10 times 10, which is 100. So 100 plus 20 plus 3, our final answer should be 123. The reason our final answer is a number is because they said and evaluate. So we needed our final answer here to be a number. All right, let's take a look at number 4. Simplify and evaluate 4 squared times 4 to the power of 6 over 4 to the power of 8. If we simplify the top of this, the numerator, 4 squared times 4 to the power of 6, that's going to become 4 to the power of 8. Because when you multiply with exponents, you add the exponents together. And now when we simplify this, 4 to the power of 8 over 4 to the power of 8, that is 4 to the power of 0, because 8 minus 8 is 0. And if we simplify that, it's actually 1. So our final answer is 1. And for the last one, simplify a to the power of 4 divided by 1 times a to the power of 3. Anything divided by 1 or multiplied by 1 is just going to be that same number. So really we have a to the power of 4 times a to the power of 3, which equals a to the power of 7. Now notice this one did not say evaluate because it just has a variable, so our final answer will be a to the power of 7. All right, we've finished these problems that we were working on together. Now I have a few problems for you to try on your own. Go ahead and pause the video here, try these 4 problems on your own, and then you can come back, watch the video, and check your answers. All right, here's the answers. Let's go ahead and talk about how to do these 4 problems. The first one, we have 1.6 to the power of 0 divided by 0.4 squared. Remember, anything to the power of 0 is 1. So really this problem is 1 divided by 0.4 squared. Let's evaluate 0.4 squared. 0.4 times 0.4, that should be 0.16. And then in your calculator, type in 1 divided by 0.16, and you will get 6.25. All right, the second one here, let's do it step by step. Again, we're going to start with the multiplication, and then we're going to add after. So 2 times 10 to the power of 3. I'm going to do that in my calculator. I don't really need to, but you can do it in your calculator. 10 times 10 times 10, that's going to be 1,000. And then times 2, that's going to be 2,000. We're adding that to 10 squared, which is 10 times 10, which is 100. And then we're adding that to 4 times 1. Remember, 10 to the power of 0 is 1. So we're adding that to 4. So when you add those all together, you get 2,104. All right, number 3. Let's start by simplifying the top. 3 times 3 to the power of 9. We're going to add those exponents. Technically, this one does not have an exponent, but anything without an exponent is the same thing as just to the power of 1. So 3 to the power of 1 times 3 to the power of 9 is 3 to the power of 10. On the bottom, I have the same thing. Remember, 5 divided by 5 is 1. 8 divided by 8 is 1. 3 to the power of 10 divided by 3 to the power of 10 is 1. And remember, if you use the same rule for dividing exponents, if you subtract the exponents, 10 minus 10, you'll get 0, and 3 to the power of 0 is also equal to 1. So that's how our final answer is 1. And the last one, number 4, we have t to the power of 0, which remember is 1, times t to the power of 7, so that whole thing is going to be t to the power of 7, divided by t to the power of 5. Remember, your rule with exponents is that you can subtract them if you're dividing, and 7 minus 5 gives us 2. All right, believe it or not, we're only halfway done for today. The first half of today was talking about to the power of 0. That was the first half of the lesson. And remember, anything to the power of 0 is 1. Now we're going to move into the second part of the lesson. In this part of the lesson, we're going to talk about understanding negative exponents. Yes, an exponent can be negative. You can have 4 to the power of 3. You can also have 4 to the power of negative 3. We're going to talk about negative exponents. We're going to figure out what they mean, and we're going to understand negative exponents in the last part of our video today. To do that, let's take a look at this problem here. 2 times 2 divided by 2 times 2 times 2. If I were to write this using exponents, I would say the top part, the numerator, would be 2 to the power of 2, and the denominator would be 2 to the power of 3. According to our rule for division, when you're dividing, you have to subtract the exponents. So 2 to the power of 2 divided by 2 to the power of 3, I would do 2 minus 3. And that would give me 2 to the power of negative 1. There's our negative exponent. 2 to the power of negative 1. So that's one way that we can simplify this problem. If we wanted to simplify it using a different method, let's say that we wanted to simplify it the same way that you simplify fractions. In order to simplify fractions, you have to look for a common factor in the top and the bottom, and then you cancel out that common factor. So we could cancel out these 2's here, and we could cancel out these 2's here, and we would be left with just nothing on the top, so we're going to say there's a 1 on the top. And on the bottom, we're left with 2. So when we simplified it the first way, we got this for our answer, 2 to the power of negative 1. When we simplified it the other way, we got 1/2 for our answer. That must mean that those two answers are equivalent. And they are. 2 to the power of negative 1 is equal to 1/2. Go ahead and try it in your calculator. In your calculator, type in 2 to the power of negative 1, and it will give you 0.5, which is 1/2. These two things are equivalent to each other. There's a key concept for understanding negative exponents. Here's what the key concept looks like. The key concept here says, for any non-zero number, that just means any number but they are not going to use 0, that has a negative exponent, you can write it as a fraction using a positive exponent. So this is what we're going to do in a couple of practice problems right now. We're going to translate between the two different ways of writing a negative exponent. One way that you can write it is you could say a to the power of negative n. Another way that you could write that same number is 1 divided by a to the power of n. So let's look at a few problems where we can practice translating between these two different forms here. Here's the first problem. They want us to simplify 13 to the power of negative 7 times 13 to the power of 4. To do that, let's start by using our multiplication rule for how to multiply numbers with exponents. Remember, as long as the bases are the same, that means as long as they're both 13 to the power of something, when you multiply with exponents, you can add the exponents together. So we're going to add negative 7 plus 4. Negative 7 plus 4 equals negative 3. So this is going to be 13 to the power of negative 3. And they say to write our answer using a positive exponent. So I'm going to, instead of writing my final answer like this, I'm going to write my final answer like this using a positive exponent here, because anytime you have something to the power of a negative number, you can rewrite that as 1 over, and then write the same thing, but instead use a positive exponent. So this is going to be our final answer. All right, here's the next one. We have simplify 9m to the power of negative 2 divided by 3m. I'm going to start by rewriting this in kind of a fraction form. It's more helpful for me when I'm trying to figure out how to simplify exponents if I write them in this form. So that's why I usually rewrite it like this. To start with, I'm going to do 9 divided by 3, which equals 3. So there's going to be a 3 on the top of this fraction here. And then I'm going to do the m part separately. I still have m to the power of negative 2 divided by m, and I remember that my rule tells me that I can subtract exponents. So I'm going to do negative 2 minus, and then this would be like a positive 1 here. So negative 2 minus 1 is negative 3. So I'm going to say this is equal to 3 times m to the power of negative 3. Now they want us to write our answer using a positive exponent. Remember how to do that. Anytime you have something that has a negative exponent, you can write it as a fraction with a positive exponent. So I'm going to say this is equal to 3 over m to the power of 3. Another way that you can kind of rewrite that is you could say that this is also equal to 3 times 1 over m to the power of 3, and then you're just going to kind of combine it all together in order to get this final answer that I got here. So the final answer is going to be 3 over m to the power of 3. All right, I have 2 problems for you guys to try on your own. Here they are. Go ahead and pause the video and try to simplify these 2 problems here. Notice it just says simplify, it does not say evaluate. Therefore, we're not going to get a final answer like 362. That's only when it says evaluate. Because it says simplify, just leave your answer using an exponent. All right, here's the answers. Let's talk about how we can get these 2 answers here. For the first one, I'm noticing that I'm dividing, and so my rule says that if I'm dividing using exponents, I should subtract them. So I'm doing negative 7 minus negative 4. Remember, anytime you have a double negative, it changes to a positive, so this is going to be negative 7 plus 4, which is equal to negative 3. So really I have 2.5 to the power of negative 3. And remember, our rule says that you can rewrite this as a positive exponent as long as you put this in the denominator of the fraction. So this is going to be 1 over 2.5 to the power of 3. And for number 2, let's start by simplifying this part right here. We have 7a times 2a to the power of negative 4. Let's start by looking at what would happen with our a's. We have a times a to the power of negative 4. This is like a to the power of 1 times a to the power of negative 4. When I'm multiplying those, I'm going to add the exponents. 1 plus negative 4 is going to equal negative 3. And then so that's going to be a to the power of negative 3. And then when I'm looking at the numbers, the 7 and the 2, I'm going to multiply those together. 7 times 2 gives me 14. So this is going to be 14 times a to the power of negative 3. Now we still have to do the first part of the problem. 14 times a to the power of negative 5 divided by 14 a to the power of negative 3. Remember how Ms. Mercer likes to rewrite these problems? I'm going to rewrite it using a fraction symbol instead. Now this helps me to clearly see that these 14s are going to end up canceling here. And I have a to the power of negative 5 over a to the power of negative 3. I remember my rule that says when I divide, I subtract the exponents. So I have negative 5 minus negative 3, which is negative 5 plus 3, which equals negative 2. So this should be a to the power of negative 2. But remember, a to the power of negative 2, you can rewrite it as 1 over a to the power of 2. All right, that's it for today. This is the only video that we're going to do this week. You are going to get to practice with it on Wednesday, Thursday, and Friday. So if you would like to re-watch this video, if you have some extra time tomorrow during class, because we're only doing IXL for about 25 minutes tomorrow, or if you have any extra time during a study hall and you want to re-watch this video, please feel free to do that. It's really important that you guys are able to understand how to do some of these problems, but you will have the whole week to practice on it. So go ahead and you guys can submit your notes to Canvas and have a wonderful rest of your day.